Hello and welcome to Tech Time Today. I am Jeff, your host, Jeff Whelpley, and this is a live stream that I am trying out. I usually do pre-record videos, and I've been trying to do more and more editing to kind of clean things up and make the videos nice. But every now and then, I want to do just kind of a quick ad hoc live stream. Today, I wanted to go over one thing that was interesting that I really got into, which is running AI models in your web browser using Hugging Face. So lots to unpack here, but what I'm going to do is actually show you a demo first, and I might go back to this since it is a live stream. I might show this a couple times depending on um, if I see a lot of other people joining or whatever to watch. But let's share screen, Chrome tab. All right, so I'm going to explain everything that's happening here behind the scenes later in a minute, but I'm just going to show the demo to start off with. So there's actually not much visual to see. There's a lot of stuff you can add to it later, but it's all running within an Angular app. Um, and so there's a couple web workers that I have created because the AI models that get downloaded and then do a bunch of processing of audio is very CPU intensive. So you really need to run it off the main thread, otherwise it's going to kill the performance of your actual web app. So we're creating web workers, and then I have it as a separate step right now to just kind of initialize the models. So this will be downloading the models I'll be using, which I'm going to show you some of the details of that. There's a website, huggingface.co, that is sort of the GitHub for AI models. You can find a bunch of free open source models to do different things. I am downloading here one to do speech recognition that takes in audio data and then spits out text at the end of the day. And so you can see that it took 4.5 to 5 seconds or whatever to download the models. So it takes time, but I mean, even downloading big JavaScript files sometimes takes a couple seconds. So for sure, depending on, you could definitely set up a user experience where this isn't that big of a deal, in my opinion. It's not like 60 seconds or whatever. 5 seconds is totally reasonable, in my opinion. Obviously, in browsers and other devices, lower power devices, it's going to be longer. So when I hit start audio capture, it's gonna, I've already given access to my mic before, so it's not gonna prompt me for access to the mic. But it'll basically open up uh, the mic and start streaming audio to the web worker, where it's gonna start running chunks of that audio through this AI model. So I'm gonna hit start audio capture, and then you'll see in just a second that the audio is being captured, and what you're seeing is the transcriptions of what I am saying. And sometimes it's not perfect. And I'll see, actually, sometimes it's not the model, it's actually my code that needs to be tweaked a little bit. But for the most part, it's pretty darn good, and it's pretty darn fast. The little delays you're seeing actually isn't even the model. The model, when it runs, is super fast, relatively speaking. It's really, I'm building in there kind of a 2 second delay so that it can queue up, like, you don't want it to run off of every little chunk of data, because that'll be like fractions of a word. You really want to send it a couple words that it can translate at a time. So 2 seconds is, I found, about right. So you can see that this is pretty darn good. I'm going to stop this now. Okay. So let's stop sharing here, and then I'm gonna actually share my code. And this is, I'll post later. I have this as an public repo on GitHub. Let's see, share screen, and let's share this right one. Yes. Okay. Uh, Let me bump up the text here so you can see. Okay. Again, I didn't spend that much time on the actual UI part of this, and this is an Angular app. If you're not familiar, it doesn't really matter. Most of the stuff is not Angular specific. Actually, the only real thing that reason why I wanted to do it specifically in Angular app is because of the way that the Angular build process sometimes handles certain things like web workers and other things like that. I wanted to make sure that it was compatible. And actually also some of the packaging for some of the libraries to make sure that they were lazy loaded and that type of thing. So there is some stuff like lower level stuff that's Angular specific. But for the most part, the code you're seeing, you could literally copy and drop in the React app or anything else. So I did split these up into different parts here, but you know, they don't necessarily have to be. So yeah, okay. So one thing is that this is all this code really needs a certain environment to be in order for it to work. So let's kind of go through those. So first of all, it has to support web workers. Um, it has to support web GPU. Okay, so what is web GPU? It is a standard by which you can have certain processes utilize your graphics card, your graphics CPU, and on your desktop, and that is sort of important because if you try to run this large complex AI model through your normal CPU, it'll be much slower. So you really, I mean, you can do it. It still works, but it's just slow then. So I guess you don't have to have this as a hard requirement. It will still work, but for my purposes, I'm saying only if it's you have web GPU enabled, which is this navigator.gpu, and WebAssembly as well. So okay, so this depends on which model you're using. Some models can run without WASM. It depends on the details of the specific model and how it is built. So the model that I'm using does use WebAssembly, so you have to make sure that that is um, the browser is capable of running it, which most modern browsers are. And then enough memory. I think I have like 8 gigs of memory available. So I kind of did some testing, and I mean, if you have 1 gig, like maybe it'll work. Like really two or more, at least for this particular model, was important. Okay. So then for creating a worker, actually, I'll be honest, even though I've tons of different um, types of web apps, I actually don't use web workers that often. I probably should in certain cases. So I actually wasn't even familiar with the API, with the way that Angular does it. Um, well, this is a non-Angular specific API. I just use it, call it creating the new worker. But when you set this up like this, Angular, the one Angular specific thing is it the build process will see this and create a separate package that is lazy loaded, and it kind of ties everything together perfectly. So this works pretty well. Was pretty excited about doing that. And you basically, I'll show you the worker in a second, but this is kind of a self-contained, should be a self-contained file. I mean, you can pull in dependencies in here, but um, it should be a separate file that is packaged by itself. Um, and then yeah, basically when something's running a web worker, you have to pass a message. It doesn't have access to the DOM directly, so you have to pass messages to and from the worker. And so the the way I send messages to it is by posting a message, and then if the worker sends a message back, it'll come back through here. So right now, I don't have anything coming back of significance, just like log information or whatever, just for debugging purposes. But you could obviously have the worker send back something, and it's arbitrary. This object, you can put whatever you want in it, both on the inbound, posting to the worker, and the outbound, kind of coming out. You can put whatever you want. So there's no like this type in it is just something I defined. It's not any standard thing. So yeah, like let's just quickly go over these parts and then we'll get into the worker. Um, Actually, want to check out one thing else before the worker. So yeah, creating the worker, initializing will actually be the thing that downloads the models from Hugging Face. Um, and then for starting audio capture, actually, there's two parts to it. One is actually starting to capture audio from your microphone, which is its own thing that I'll actually show first. And then as audio is coming back from your microphone, so like it comes back in audio chunks, um, and so then you would send those chunks one at a time to the worker to be processed. Okay, so let's actually go into the microphone capture streaming here. So this is not in a worker yet. This is just, and this is not using any AI stuff. This is really standard web audio stuff. Most people that have done anything with users uh, media, like either microphone or camera or whatever, will be familiar with this type of stuff. There's one thing though that's, I guess, unique. Um, Well, maybe a couple things. So one, it's important that the sample rate is the same in the audio context here, and that the audio context that in the model when it's doing its pre-processing, that's actually pretty important. So you know how much, so it knows how to convert the raw audio to tokens that can be passed into the model. So I'm six, 16 kilohertz is pretty standard, I guess. It's the one I've been testing with. And oh, the one other unique thing here, or somewhat different than what I'm used to, is that uh, we have to stream the audio. So like, or well, we don't have to, but the way I'm doing it is streaming it on a continuous basis. I'm not just capturing one set chunk and then sending just all the audio at once. I'm doing it on a continuous basis. And so in order to do that, I tried a couple different methods. It was actually harder than I thought. The thing that I got to work was to use this thing I actually honestly never heard or used of before, this audio worklet, which is similar to, it runs in a separate off the main thread, similar to a web worker, but it isn't technically a web worker. Um, Whatever, it's a worklet. But basically what this does is it's sets up the audio context where it pulls in from the source the microphone, and it connects it to this worklet, and the worklet is the thing that the um, converts the microphone audio to the actual float 32 array. Like that's the format it has to be in, or that I have it in at least when I send it to the worker. It just makes things easier to get it in that format before you send it over. So the one, I mean, this has nothing to do with AI or web workers per se, but one small thing I guess I was going to mention is that this thing for adding the worklet module, you have to do it from a URL as a separate file, but I couldn't for like unlike this part that Angular packaged perfectly and set up as a separate a separate lazy loaded package, and just worked. When I tried to do that same thing here, it didn't, and I suspect it's because the Angular build system. I don't know underneath the scenes how it works, but it must recognize this format for web worker and creating the separate lazy loaded package automatically, but it must not understand the worklit add module. I'm pretty sure this is a really new API, so I guess that's not surprising. But the workaround I found is that you can basically have it the instead of having this in a separate file, you just have it as a string and you create this blob object URL. So it's a URL, quote unquote, but it's really just like a string that you're passing right to it. So that gets around some of that issue. So end of the day, what this code is doing is it's using this worklet to do a little bit of pre-processing of the raw microphone audio to get it into these audio chunks that are in float 32 array format that are sent to, uh, like I said here, they're sent to the worker in these chunks. Okay. All right. Let's get into the actual worker. Um, okay. Uh, so the only dependency here is Hugging Face transformers. Okay. I spent a ton of time on the all the documentation I could find, examples that people gave, etc. It is really difficult because most of the examples are in Python, or if they're in JavaScript, they're in Node code, which is slightly different. There's a lot of like server only um, dependencies within Hugging Face that work on the server side, but not on the web. And so most of the stuff that they have on the main Hugging Face transformers.js site and everything like that, I found didn't work for me when I was trying to do it. So, like for example, the main some of the main documentation says to use this pipeline function from this Hugging Face transformers library. Uh, but as far as I can tell, that only works on the server side with Node. In the web, I had to do things a little different using these kind of lower level um, uh, objects, auto tokenizer, auto processor, and this Whisper one that specifically is used for the model that I'm Whispers. As you can see down here is the name of the model I'm using for speech recognition, and so this is related to that for it helps to generate the model. So yeah, in theory, if it was able to get the pipeline to work, you wouldn't have to pull in these like lower level things. So hopefully they eventually get that to work. For now, uh, you use this, or you have to look into this. If you're using a different model, you have to dive down into the details of it to see what are some of the specific uh, things that are needed to execute it. And usually in Hugging Face for the specific model, they have some example code there. So that's actually where I ended up getting some of this. I had to adapt it a little bit. It didn't work exactly, but on the I'll go to that in a minute. I don't want to switch screens right now. Okay, so sampling rate again. This matches what was on the when we were capturing the microphone audio and the audio context, 16,000 hertz. Um, okay, so I'll show this later, but these variables are basically batching up. So we're basically sending all these audio packets to this worker process. And like I said, an auto packet may only have like a fraction of a word. It may just be like you speaking one word may get split up into like 3 or 4 different packets. So you can't just translate each of those individually. So I queue them up into segments of 2 seconds, which seem to work about right to do that at a time. And I'm doing an overlap because of 200 milliseconds because um, if you, depending on how you split up your, it may split a word in half. And so it may not seem like a lot, but 200 milliseconds when you're speaking, that actually does pretty much capture most words. To make sure that you won't split it in half. The one downside of using this overlap method, that I'll show you the algorithm for in a second, um, is that sometimes in the transcription you'll see the same word twice uh, at the end of one iteration and the beginning of the next iteration because there's this overlap. But that's not that big of a deal, at least. I mean, it depends on what you're using the transcriptions for, I guess. But I've found that not to be that big, especially if you're feeding your transcriptions into um, an LLM. The LLM very easily handles if someone repeating one word periodically. Okay, yeah, like I said, this is the model I'm using. There's many other speech recognition models on HuggingFace, and I tried a couple of them out. Some worked, but they were much bigger. Some didn't work as well. This honestly was the best one that I found. Like I said, I'm using web GPU, so there's a piece further below that specifies that. So in theory, there's different versions of. So even though I'm using this model has different versions of it. It's just with the way that it's packaged, and there is like a kind of uh, quantized version that is smaller and in theory would load quicker. And then you would have to change the model format if you change the different type of one of those other quantized versions, or maybe there's um, other ones other than that as well. But and I tried that out. They didn't work as well. Some of them didn't work at all. This was the one that worked best for this. So this won't be the same for every model you like. A lot of this stuff. I mean, I've only been focused on speech recognition, but if you're trying out to do other things, um, I think a lot of this gets uh, if at some point that pipeline function starts working in the web, I think this is what it abstracts this stuff out, so you don't have to like manually deal with this level of stuff. But otherwise, like I don't know, you have to look at the documentation for the model. If it's not there, it's trial and error. At least it's kind of wild west a little bit for a lot of this stuff. Um, a lot of, especially if it's a model that's not being used very often by other people, and especially not being used at all in the web specifically. We're only interested, or I'm only interested in English. This model does do other languages, but you do have to specify when you do the transcription what language you add. There's a whole separate model for trying to detect what language it is. So, like again, if you got that pipeline function works with the higher level API, which is really nice. You're able to kind of link different models together. And so in theory, you could have a language detection model that figures out what languages and then feed it into the speech recognition after that. And this just helps to limit for the tokenizer at the end, or actually for part of the model too. Um, since we're only doing 2 seconds of audio at a time, it's not words actually. It is tokens. I don't know why I put words here. Let me change this now because tokens and words are not the same. But 64 is way more than enough for 2 seconds. You're not going to need more tokens than that. All right, and then So like I said, we're kind of queuing stuff audio up as it comes in this audio chunk buffer. Here's the different parts of the model that's being downloaded. And then this is part of the web worker that when the main thread sends messages in, it tells the worker to do different things. So I have just this format that I set up for, okay, if it tells me to init, then initialize the model. If it tells me that it's sending an audio, then all I do is concatenate it to the buffer. So let's keep going down. So when we're initializing the model, so this is the code that takes 5 seconds or about that because it pulls down these humongous models from Hugging Face. One interesting thing, which I didn't do this version, I am going to add this later, is that uh, potentially, even with the same exact models, you could get this faster. If you, I was trying out you can download the model manually from Hugging Face and then upload it to Cloudflare Edge servers, and then have this code, instead of downloading it from Hugging Face, you download it from those Edge servers. It's more complicated. I started to look down it, um, and I just put it aside to do the easier thing for right now. I'll try to add that later, but I think that would be interesting to see what it would take to download from just kind of other arbitrary places. Um, okay, so this downloads loads up the preprocessor, the tokenizer, and the model. So it's finished, and then runs this audio processor. So this daemon is like, so we're creating this queue, and then um, basically this process is just looping, waiting for there to be enough audio in the queue to process. So the audio processing length, like I mentioned, is essentially 2 seconds. So essentially this is saying when there's 2 seconds of audio in the buffer, then we process it. So we take out those 2 seconds and we send it to, and make sure that the overlap is still there in the buffer, and then we process it. So let's look at that. Okay, so essentially 3 steps. I mean, simple steps at this level. It's really complex under the scenes. But the preprocessor takes that float32 array representation of a chunk of audio, and it converts it to extracts features. So like that means basically converting it to a different format, and it depends on what the model is. So different models require different inputs. Um, so it's not like you can't just throw that raw uh, float32 array into the model. It won't know what to do with it. So there's a preprocessor that converts it to the format that it wants is log mel spectrograms. Uh, I actually looked into it first, how to manually do this. It is actually super complicated. So I'm glad I finally got a preprocessor that worked correctly. Because if you have to do this manually, converting float32 array to log mel spectrograms, uh, it's pretty involved. So, so thankfully, this is just one quick and easy line of code. And then next is the model. So this is just the config for the model and the model itself. Uh, so nothing too crazy here to talk about. The model will take in those inputs, take in the features, log mel spectrograms, and then it'll output a bunch of tokens, some output tokens. So those output tokens are not words. They're not things you can actually read, your normal English language words. It's different. It's the AI, the model representation of those different tokens. So you need a tokenizer to take them and then turn them into human readable text. Um, so that's what this does here, and then we basically post that text back, which we saw in the demo, which I'm going to do again just in case in the live stream somebody joined that hadn't seen this. So let me go back here, stop, share. Okay. And so just to show again, so I'm creating my actual worker, initializing the models, which take about 5 seconds or so. These are just some warnings. It's not that big of a deal. See, 4.5 seconds, great. And now I'm starting to capture audio, and in just a second, it will start to print out what I am saying. And if I stop saying something for a second, yeah, it'll show that blank audio. So that blank audio means that basically, there were audio packets. There were 2 seconds of essentially silence that were sent in, and the model could not figure out what it was actually. Well, basically saying that no, there's no words in here, so it was silence. So yeah, this basically works. It's pretty cool. Okay, let's talk about for a second of why this is cool. Okay, so a couple things. Clearly, you can stream audio to a backend and have the backend do all of this, and there's plenty of places to stream audio to any one of these. There's plenty of transcription services out there. Um, there's sort of two big reasons why this matters. One is that it is a lot cheaper than using either running your own models on the server or sending the audio to transcription services. I mean, Get Human, my company spends you know $10,000 a month on transcriptions. It's like crazy, and we need to because we need to be a certain quality and whatever. But depending on use case, if you can, for whatever it happens to be, if you have the AI models, like it's a open source model and it works well and it runs in the browser and you can get the UX to be good for the user, it's basically for free, which is amazing. It's using the user's processing time and everything. So that is like a huge thing. Also, there's a privacy thing. Like so, um, you know, depend again. This depends on what you're trying to do and everything like that. But the model running in the user's browser on their side, you're not sending the data, or you don't have to, I guess, send it back to some server or whatever else. Um, and I focused on speech recognition, live transcriptions for I guess two reasons. One is that I do use that for the main app that I work on at Get Human all the time, so I'm kind of familiar with it. But also, text is yeah, okay. Some of the LLMs uh, allow you to speak to it now, which is great. Uh, but a lot of them still require text. And actually, even if you allow them to speak to it, it can be tricky. Or if you're trying to, depending on what you're trying to do, it can be tricky in terms of building that within an app. But text is pretty easy to deal with and manipulate and send to different LMs. So essentially, this I feel like this speech recognition thing, turning your words into text, is the critical like first step to then also various different AI related things you can do from there. So it can be potentially super useful. Like yes, that I'm gonna like look into running a bunch of other types of models on the web, and I think that it can be super useful in different ways. But I started off with speech recognition because I feel like that is like a big starting point for a lot of different things, and I think it could be potentially useful for a lot of different people. So hopefully you uh, think that it is useful. I'm gonna post the. I'll share the location of the. Uh, yeah. So it's on my GitHub. github.com/jeffwellplay/angular-transformers. I have everything checked in here. Oh, I'll change the README because it has the default stuff that I did an ng generate on. So I'll try to write some more useful documentation in there right now after I get off this. But feel free to grab it and play around. I mean, it should be as easy as downloading this, and you should be able to run it and it just work. Definitely let me know if you run into issues. And I'm gonna over the next couple days, I'm gonna do a couple other videos on related things. So like I think tomorrow potentially, if I have time, I'm gonna do kind of a somewhat higher level thing, just talking about the entire landscape of AI in the web. So I'm using the Hugging Face transformers, but there's a couple other things you could potentially use out there. That's just like kind of one approach. So I kind of want to give a layout of some of the different approaches that people have used and what I found works and doesn't. So hopefully that'll be helpful. And then once I have this cleaned up a lot more, I'll do another one of these in more kind of refined fashion. This was more pretty ad hoc, just quickly going through it. And that's about it. So thanks for joining me. And hopefully I will see you guys in the next Tech Time Today, which should be tomorrow. Yeah.